coders, welcome back to the channel of GDDG Today we are going to solve problems of Starters 251 contest on Codechef. Let's start. Our second problem is bus rows. In the question we are given that we have a bus with n rows and m seats in each row. Our seat number is x and we can enter the bus from either the front or the back. We need to find the minimum number of rows you have to walk through to reach our seat, including the destination row. This have to be kept in mind, destination row. So first we find which row contains seat X and then choose the shorter distance from front or back. So finding row would be enough for this problem. Suppose example is n is equals to 4 and m is equals to 2 and x equal to 4. Let's take this example. There are 4 rows and 2 seats in each row. Row 1 contains seats 1, 2. Row 2 contains seat 3, 4. Row 3 contains seats 5, 6. Row 4 contains seats 7, 8. Our seat is 4, so it is in row 2. From the front, we need to walk 2 rows. From the back, we need to walk 3 rows. So the minimum of 2 and 3 is 2. Therefore, the answer is 2. That means we need to find the minimum of the value from both front of the bus and from the back side. So let's understand the code. Here we will take the number of test cases first. We input n, m and x. Int row equal to seal x by m. What does this mean? We will divide x, that is here x is the number of your seat number. So we will divide the seat number with the number of columns, like the number of seats in each row. This finds the row containing x. After finding the row, we will just print minimum of the row. This will print the row from the front and this will print the row from the back. Now moving on to the next question, make multiple. We are given an integer n. In one operation, we can do either of these two things, add 1 to n or replace n with the smallest multiple of 5, that is strictly greater than n. Our goal is to make n divisible by 3. We need to find the minimum number of operations required. Let's understand this with the help of example. Let's take this test case. Since 10 is not divisible by 3, we need some operations. So first was add 1. If we will add 1 to it, then it will give 11. But 11 is also not divisible by 3. So we will take another case, that is go to the next multiple of 5. So the next multiple of 5 for 10 would be 15. And 15 modulo 3 will give remainder as 0. So the answer is 1. Let's understand the flowchart. Here first we will start with the input. We will check whether the number is the multiple of 3 or not. If yes, the answer is 0. If it is not the multiple of 3, we will make it using some operations. We will find the next multiple. How to find the next multiple? It's very simple. We will take an example to understand. If the number is 45, then if we divide the number by 5 and we will get the quotient 9 and remainder as 0. So if the quotient into 5, that is the number itself, and 5 minus remainder, that is if we subtract remainder from 5, then it will give the next multiple. Let's understand. N here is 45 and if we will subtract 0 from 5, it will give 5 and this will give the next multiple as 50. So this is the formula. Let's understand. So if after finding the next multiple, we will check if any of the conditions is true or not. If n plus 1 modulo 3 equal to 0 or the next multiple modulo 3 is equal to 0, If the condition is true, then the answer is 1. And if the condition is false, then the answer is 2. Let's understand the code. First, we will take the number of test cases. Then we process every test case. Then the step is to check if n is already divisible by 3 or not. If if the remainder is 0, we don't need any operation. Next step is to find the next multiple of 3. As I have already discussed in the flowchart, n plus 5 minus n modulo 5. What is this n modulo 5? This is the remainder. N plus 5 minus remainder. This is the n modulo 5 will give the remainder. So this will store the smallest multiple of 5 strictly greater than n. So next step is to check if one operation is enough or not. Next multiple on. If next multiple on modulo with 3 will give 0. This checks whether replacing n with the next multiple of 5 makes it divisible by 3 or not. And the next condition is n plus 1 modulo 3 equal to 0. This checks whether adding 1 to the number makes n divisible by 3 or not. If any of the case is true, the answer would be 1, else the answer would be 2. This answer would be 2 when neither of the operation works in step. So this is the code for the problem. Now let's understand the next question, chocolate game. You are given n boxes and each box has some chocolates. There are two players, Alice and Bob. The important rule is if the total remaining chocolates are even, Alice gets the turn. If the total remaining chocolates are odd, then Bob gets the turn. On their turn, a player can choose any one box and eat any positive number of chocolates from that box. They do not take turns normally. The same player can get the turn again if the total parity remains suitable. Both Alice and Bob play optimally, meaning each wants to maximize the total chocolates they personally eat. So our task is to maximize the total number of chocolates that Alice will eat. So let's understand this with the help of example. If we take this example, like we are given two boxes with 3 chocolates in each box, then what will happen? Since 6 is even, first 3 plus 3 will give 6. 6 is even, so it's Ellie's turn. And there are two odd boxes. Elise can play in such a way that she eventually gets 5. So answer is 5. What will happen here? First, there are 3 chocolates in both the boxes. So answer would be 6, which is even. So Alice turn because it's even. Then Alice will eat 2 chocolates from the first box. So only 1 chocolate will be left in the first box. So 1 and 3. So 1 plus 3 will give 4. Again, it's Alice's turn. Then she will eat 2 chocolates from the second box. This will decrease the chocolates to 1 and 1 in both the boxes. And on adding it again, we will get 2, that is even. So again, it's Alice's turn. Alice will get 1 chocolate from the second box. There is now 0 in the second box and it will give on. So now finally it's Bob's turn. Then Bob will eat 1 chocolate from the first box and the last, which is the last chocolate. So in this way, Alice has managed to eat 6 plus 4, sorry, 2 plus 2 plus 1, that is 5 chocolates. So she cannot eat any more than this on playing with Bob. So the main logic is in this code is that we will let the sum equal to total chocolates and odd is equals to what? Number of boxes containing an odd number of chocolates. So here we will use the logic that if our sum is even, then we will simply store Ellie's answer equal to sum minus odd by 2. And if sum is odd, then Ellie's answer is odd by 2. This is the simple logic we are going to use. Let's understand the code. Here, first we will take the test cases, then taking all the inputs. Then we will take the sum, that is the total number of chocolates in the boxes is using this one, and odd, as I have already told. Then case 1. First of all, what we will do? Here what we are doing, for every box, we are storing sum plus equal to x. This will add its chocolates to the total. And now here we are storing, checking whether the number is odd or not. Now, case 1 is total is even. If the sum is even, then Alice will start. Her maximum chocolates are sum minus odd by 2. So we will print that. And case 2 is odd. That is, if the total is odd, then what we will do? We will just print odd by 2. Here, what is happening? If the total is odd, Bob will start. So Alice's maximum chocolates are odd by 2. The complete idea is that first we will calculate the sum, then count the odd boxes, then we will check is the sum even. If yes, then then we will print sum minus odd by 2. And if the answer is no, then we will print odd by 2. So this is the overall code for the problem. Now, if you found this video helpful, please like the video, share it with your friends, and don't forget to subscribe to the channel GDG Triple MUT. Thank you.